Ladies and gentlemen, in my astronomy class, Monday night, I hope you do well and everything goes well. I'm going today to talk about chapter 7, which again, this is from your 11th edition, which in 10th edition, this is chapter 6, so nothing is changed. Okay, everything is same, just in 11th edition, it's chapter 7. In 10th edition is chapter 6. Okay. Uh, Chapter 7 is about Earth and Moon. So if you remember in chapter 6, the topic was formation of our solar system, which I started from a Big Bang, then hydrogen and helium, they formed in our universe, then stars formed, galaxies formed. So, and then super nebula, which it is fusion, explosion of stars and forming heavy elements like iron, uranium, like oxygen, and even carbon. And then we learned how the solar nebula formed and then rotate, and then density, temperature, gravity, collision. These were all caused in formation a very big ball at the center, which is called protosun. Then protosun, because of gravity again, rotation, conservation of angular momentum. So these all temperature and density increases. So protosun converts to the sun, which differences between protosun and sun is temperature. So when temperature reaches to close to 10 million Celsius, protosun is not anymore protosun, so it's called the sun, which it's good condition to fuse hydrogen to helium. And then we saw the other planets formed also around the sun. Uh, so chapter 6 was about formation of our solar system. In chapter 7, we will learn only about our planet and moon. And then in chapter 8, we will learn about inner planets, which they are Mercury, Venus, and Mars. And then chapter 9 will be about outer planets or gaseous planet, which they are Jupiter, Saturn, Uranus, and Neptune. So chapter 7, I'm going to start with one question, that why our planet Earth is a unique planet. So I will say that Earth is a unique planet. Let me do by black. Why? What do you think? Why is our planet a unique planet? We might have many several answers, but the first one maybe I will say because of its atmosphere. So I want you please to think. So our planet is a unique planet because of its atmosphere. What else? The planet Earth is a unique planet. Why? I will say also because it has the water. Yes. Our planet Earth is a unique planet. Why? What do you think? I will say also because it has magnetic field. I will say our planet is a unique planet because what? Because it is at the proper distance from the sun. So, distance. What do you think? What is number 4? Our planet is a unique planet. I can say because of its moon. Our planet is a unique planet. I can say because it has only one star. So I will say it has only one star, which it is the sun also. You know, majority of the planets that we do have in our galaxy, so I'm talking about our galaxy, which they are called exoplanets, they are in binary system. What is the binary system means is their solar system has 2 moon instead of 1 moon. As I said in chapter 5, if Jupiter had 75 times, if it was more massive than it is today, it would be star. So our solar system would have 2 stars, which I don't think so we would have life on the planet Earth in that time. What do you think about number 7? Why is our planet a unique planet? Its atmosphere, because it has water, because it has magnetic field, because it's in good distance, because it has moon, because it has only one star. And what do you think for number 7, what we can say? It has seasons. These are all reason. Which season comes because it's tilt. Number 8, because of its rotation. Let me just give you one example. Planet Earth orbits the Sun in 365.25 days, but planet Venus orbits the Sun in 242 days, but the length of the day on the planet Venus is longer than the length of the year. Does make sense? So one day on the Venus is longer than 1 year. 1 year means is one complete rotation about the Sun. One day means is one complete rotation about itself. So one complete rotation about itself for planet Venus, is longer than one complete rotation of the Venus above the Sun. But planet Earth rotates once a day above itself. It rotates 365 times in 365 days. So planet Earth is a unique planet, yes. So the first topic that I'm going to talk actually about that, it is atmosphere. So the Earth atmosphere. Watch guys, the atmosphere that we do have it as of now, it's actually third generation. So the atmosphere that we have it, we breathe it today, it is third generation. What is third generation means? Third generation means is this. If we go back at the beginning of formation of our solar system, like 4.6 billion years ago, so uh, so the first generation of Earth atmosphere was actually at the beginning of formation of solar system. So it backs to 4.6 billion years ago. Okay. So what we had in that time, guys, so let's say this is the planet Earth, all right? And after formation of Earth and solar system, the main gas in Earth atmosphere was hydrogen and helium gas. So don't forget this. So after formation of solar system, the major gas, the main gas in our Earth atmosphere was actually hydrogen and helium. These gases actually they are very light gas. So uh, what happened? Here is the sun, correct? And the sun is energy actually. So the sun is energy, and energy we know because it gives heat, and not just heat, UV, IR, all electromagnetic wave spectrum. Uh, so these hydrogen and helium gases, they gain energy. So I want you to please learn it. They gain energy. When they gain energy because of that heat, so energy is heat, okay? Or heat is energy. So they gain energy from the sun, they gain heat. Then this heat converts to kinetic energy. What is kinetic energy? Is motion. So kinetic energy in reality is what? Is speed. It's motion. Make sense? So what is happening, guys? These gases actually they gain energy, then they gain speed. Okay, so they overcome on gravitational force of the planet, and finally, what they escape. So in reality, the first generation of planet Earth, which it was hydrogen and helium, but uh, in very short time those hydrogen and helium they overcome on gravitational force of the planet Earth, and finally they escape out, and therefore we can say the first generation of Earth atmosphere was almost empty. Okay, so the first generation was almost empty. uh, Let me tell you one important thing. Look, guys, there is no exact date that, like, if we say 4.6 billion years ago, planet Earth formed, okay, then how long Earth atmosphere was empty, there is no exact date. But geologists, uh, they believe with some uh, datas that this lasts for 500 million years to 800 million years. So 500 to 800 million years after formation. So again, this is not correct. I'm sure it's not correct, but almost we can accept it. but it's not exactly correct. So let's say 500 to 800 million years ago, sorry, 500 to 800 million years after formation of uh, solar system, the Earth was the Earth atmosphere was empty. Now let's go on second generation. That what is happening. So I want you to also please study uh, this section from chapter 7. You will learn more. So part 2, I'm go over second generation of Earth atmosphere. What is happening here again? So let's assume if this is planet Earth. Okay. As you know, we have a lot of cracks. I don't know, even volcanoes. We have earthquakes, so we do have volcanoes. We do have earthquakes. And also we do have a lot of cracks, which these cracks actually they extend from inside the earth, which is called core, and finally they come to the mantle and crust and to the surface of earth. So the carbon dioxide, which it's called CO2. It was the major gas, and it is also that this gas ejects out from inside the earth by these cracks, by earthquakes, and by volcanoes. It ejects out and it came to the earth atmosphere. And it was not only carbon dioxide, also it was water vapor and nitrogen. So nitrogen and also water vapor. So what is happening? So we have three main element, which main section is carbon dioxide, nitrogen, and also water vapor. Okay. Now, this carbon dioxide, which stays in Earth atmosphere, it was thick enough. So it was really thick. It was close to 150 to 250 kilometers from the Earth's surface. So carbon dioxide plays the main role, the main game in formation of greenhouse effect. What is greenhouse effect? Greenhouse effect is, let's say, here is the sun, all right? And this sun gives energy. When this energy hits the Earth's surface, of course, it reflects. So when it reflects, it doesn't go outside. It like traps inside the circle. So again, it reflected inside. This was caused to increase temperature of Earth atmosphere, which it prevents planet Earth from freezing. So time goes and goes. Time goes and goes. The chemical reaction forms between carbon dioxide, nitrogen, and water vapor. There is of course a lot of questions that how this happens. So if you find biologists and chemist persons, you can ask them actually, but uh, geologists and biologists also, they believe with many data that chemical reaction between carbon dioxide, nitrogen, and water vapor finally it changed the atmosphere to third generation. But how long this generation, which is second generation of Earth atmosphere, lasted? It says from 1.5. It is actually, let me, so this goes to 800 million to 2.2 billion years after formation. Okay. Then ocean forms, life starts. Photosynthesis was the main reason in keeping balance between carbon dioxide and also oxygen. And finally, third generation forms. Let me tell you one important thing. If we were in this time, like 800 million to 2.2 billion years after formation, guys, the second generation of the Earth atmosphere was like Venus atmosphere as of today. So the Earth's second generation, so the Earth second generation of atmosphere was same atmosphere as Venus has today, so extremely hot. Now, let's go on third generation to see what is going on here. It is as of today. So it's 2.2 billion years after, too recent. 2.2 billion years after, 2.2 billion years, yeah, after formation to today, it's third generation of Earth atmosphere. What is the major gas of third third generation of the Earth atmosphere, it is two main gases. So please pay attention. These are all questions. The first one is nitrogen. So N2, it's called nitrogen gas, which it is 78.1%. So 78.1% of this atmosphere is nitrogen. Oxygen, which we showed by O2, it is 21% almost. And other gases, it's almost 1%. Like what? Like methane, like CO, monoxide carbon or carbon monoxide, like iron oxide, and other gases. So if you pay attention here, guys, the main part of the Earth atmosphere is nitrogen and oxygen. 78% is nitrogen, 21% is oxygen. Now, so if I go on PowerPoint, what we have, this is why this doesn't work. Okay. This is the Earth atmosphere, which it's made actually by 4 different layers. Layer 1, it's called troposphere. Now I want you to pay attention. The first layer is called troposphere. What is the height or altitude of troposphere? It's almost 11 kilometers. 11 kilometers is close to something like 37,000 feet. What we see in this graph, as altitude increases, as we go higher, temperature what? Decreases. Which nitrogen and oxygen are actually in first layer, troposphere. So the weather that we breathe, it's troposphere. It's nitrogen and oxygen. Then the second layer, it's called stratosphere. So what we see in stratosphere, also it's called what? Ozone layer. What I see in stratosphere or in ozone layer, as altitude increases, temperature also increases. Then what I see on part of mesosphere, let me tell you, what is stratosphere? It is made by 3 oxygen atom. It's called O3. And then we have mesosphere, which it's very hard to do research and investigation, study about mesosphere, because mesosphere are the sum of heavy elements, which these heavy elements, they are debris of meteors. When it goes inside the atmosphere, when they burn, actually that smoke, it's in this section. Usually satellites, they are orbiting the earth more farther than mesosphere. So satellites cannot stay in mesosphere. They need to be very high speed, which that is very hard actually. But usually it's the layer of smoke. What kind of smoke, what kind of particles they are? They are debris or smoke lasted from burning of meteors. And the fourth layer, it's called ionosphere or ionosphere. What is that? By the name we can say they are ion. So where they comes from actually, these particles, they come usually from solar wind. What is solar winds? They are charged particle. That's why it's called ionosphere or ionosphere. So they comes from solar wind actually. And we see if altitude increases, temperature also increases. Now you can see how is the temperature in these layers. In the first layer, temperature as altitude increases, temperature decreases. Then in stratosphere, as altitude increases, temperature increases. In mesosphere, as altitude increases, temperature decreases. Then again, temperature increases. So it's like zigzag. Okay? So remember our planet Earth. Our planet Earth has, so if this is Earth, 4 major layers. This is layer number 1. This is layer number 2. This is layer number 3. And this is layer number what? 4. So what is the layer number 1? It's called troposphere. The second layer is called stratosphere. These are important. You have to know them by order. Third layer, it's called mesosphere. And fourth layer, it's called fourth layer, ionosphere. Okay. So you know troposphere is nitrogen and oxygen, which nitrogen is 78%, oxygen is 21%. And the ratio, if I ask you this question, what is the ratio of what is the ratio of nitrogen to oxygen, this is N2, this is O2, your answer is 4/1. This is the ratio of nitrogen to oxygen, 4/1. All right. So this is about third generation of the planet Earth atmosphere. So guys, today, what generation is the Earth atmosphere? The answer is third atmosphere. The second atmosphere, actually we had greenhouse effect. It was very hot. It was like the Venus, planet Venus atmosphere as it is today. And the first generation was almost empty. Why? Because after formation of solar system, hydrogen and helium were the only gases that left in the Earth atmosphere. But after elapsing time, they gain energy because of the sun. So energy means it's kinetic energy. Kinetic energy is motion, and they escape from Earth gravitational force. So the first generation Earth was empty in atmosphere. Now, what is greenhouse effect? Let me explain you. Look guys, usually you notice that if you keep your car in front of the sun, and also if you don't close your windows, even during the winter, inside the car will stay warm and even hot. Why? So here what you see, external temperature is 71 Fahrenheit, but internal temperature, or inside the room, inside your car, temperature is like 82 Fahrenheit. So what does that mean? Let me explain you this. So what is greenhouse effect? Watch guys, imagine, no, this is not good. Let's say here you have a brand new, for example, car. And inside your car, of course, you do have seats, correct? Inside your car, of course, you do have carpet, correct? You do have steering wheel, for example, you do have dashboard here, correct? And you have many things. Here is the sun, okay? This is greenhouse effect. When the sun incidents energy or photon, so this is electromagnetic wave, correct? Then this electromagnetic wave, which it has its own frequency, correct? It goes inside your car from windshield, from door glasses. So what is happening? This photon, which it is energy, gets absorbed by by the carpet, by the seats, by dashboard, by steering wheel, by many things. So it gets absorbed by all of these elements. When it gets absorbed, okay, of course we have absorption and we have reflection. So some part of this electromagnetic wave reflects out. Because this light already lost its energy, so its energy is decreased, is less than previous energy, so it cannot go out of the car. So it traps inside your car again. And then this becomes absorbed by this seat or by this carpet. Okay. Some of them it's reflected. It wants to go out, but it doesn't have enough energy, so it reflects inside again. So it traps inside. So there is no place, no room to, this electromagnetic wave to go out of this car. So what is happening? Temperature inside the car increases. This is called greenhouse effect. So same thing happened in the second generation of Earth atmosphere. So if we say this is Earth, okay, this was the Earth atmosphere 2 billion years ago almost, which is the second generation. Then the sun is here, correct? So what is happening? Electromagnetic wave, they hit the Earth's surface, then they reflect, but they cannot reflect. They get absorbed by these gases, correct? So when they get absorbed, they cannot go outside, so they reflect, so they stay in this area. So what is happening? The temperature increases. This is called greenhouse effect. Okay. So if I show you some pictures, so these are the pictures that you have it in your book. So solar radiation, then it gets trapped by the planet's atmosphere. Of course, some part of that goes out, but some part of that reflects, so it traps inside the Earth atmosphere. Therefore, this is what happening. Temperature of the planet Earth increases. So, planet Venus is extremely hot. The temperature is close to 720 Kelvin or 900 Fahrenheit is the temperature on the planet Venus surface. Why Venus is hot? Because Venus has the thickest atmosphere in our solar system's planet. So the Venus has the thickest atmosphere. So that thick atmosphere actually it's caused to play greenhouse effect. So greenhouse effect, it doesn't let electromagnetic wave goes out of the atmosphere, it reflects inside, so it traps inside the planet. That's why temperature increases. This is what we have today. So now the next section, yeah, so these are already, I explained them. Okay, watch guys, I think it would be very good if I would say why is our planet unique planet? Because Earth is a live planet. Earth is not dead. Earth is a live planet. Uh, as you know, this is the map of Earth today. So Africa is here, South America is here, Central America is here, North America is here, China is here, Australia is here, Europe is here. So this is today, okay? But if we go back like 152 million years ago, look guys, this is the picture of lands on Earth. Look at where is Antarctica, where is Australia, where is India 152 million years ago, where is Africa, then North America, you know. Now I want you to compare it with this place. Look, just watch differences. Just watch differences. Correct? Now if I go back to 237 million, watch. 152 million years ago, this was the map of lands. 237 million years ago, this was the map of lands. Correct? So what is happening? The lands are moving. The lands are moving. Why? Because planet Earth is actually live planet. It's not dead. It's because of tectonic. So continents are moving. So lands is moving. So the location of continents actually changes. Why? Because Earth is a live planet. Because Earth core is different with any other planets in our solar system. I'll explain it in the next section. Okay, so you can study this section, please. Now, the next section is about Earth's interior. What is the inside the Earth? What do we have? How many layers do we have inside planet Earth? Okay. Here, I need to define you this. What is seismology means? Seismology means is study about wave formed by vibration, earthquakes, and even volcanoes. It's called seismology. So, you know, if you uh, make impact between two objects, they create actually wave. Now, if Earth vibrates, it creates wave. maybe some waves are like this, correct? A machine that records the shape of wave, it's called seismograph. Usually if you go to geology lab, you will find always in this machine. If you go to MJC, they have it one in science building. If you go to Merced College, also in geology lab, we do have this machine. So guys, if we do study about, so if we measure, the amplitude of this section, if we measure the amplitude of this section, if we measure the amplitude of this wave, so these all, they will give us some data such as what? Wavelength, period, and frequency, and also amplitude of wave. If we analyze these data, we can figure out actually thickness. We can figure out actually composition or kind of material. We can figure out also temperature. And also we can figure out what? Pressure. So this is different major. So if you go to be a geologist, which is very good major, you will study about seismology. Okay? But just I give you introduction about seismology, that if we measure wavelength, this is the period, not temperature. F is frequency, and A is amplitude. I already explained it in chapter 3. And lambda is wavelength, right? Then we can figure out some important quantities, which like thickness, material, temperature, and pressure. Now, so knowing these data, guys, geologists, they believe, pay attention here, that uh, the earth actually is made by 4 different layers. So the earth is made by 4 different layers. It's called Earth's interior. Please pay attention, these are important, they will be questioned. The first layer the first layer, so let me call this one is number 1. It's called iron core, but it is inner core. So it's called inner iron core. It's called inner iron core. What do we have in inner iron core? 80% is iron, 20% is nickel. So 80% is iron, 20% is nickel. And you know what? More important, it is solid. Also it is solid. And more important, temperature of the core is like 5800 Kelvin to 6000 Kelvin. Let me see. Yeah. Yes. So it's like 5800 Kelvin or 6000. Yes. Let's say Celsius. So temperature of inner core is 58 to 6000 Celsius. It's almost same temperature, very close temperature to the sun's surface, to the surface of the sun. So the core is two sections. One is called inner core. The second one is called what? Outer core. So this one is outer core. So number 2, it's called outer iron core. So what is that? This is also 80% iron and also 20% is nickel. But what is differences? Differences is it is molten. It's molten iron. It is liquid. It's not solid. What is temperature? It's vary from 6000 Celsius to geologists they believe 800 to 4000. Okay, I go with 4000. Again, these numbers are not absolutely correct above temperature. Okay, they are approximation. They are almost, but they are not 100% exact numbers. Of course, we have plus minus. So what do we see, guys? I see temperature here is 6000 Celsius, and temperature on the upper section it's 4000 Celsius. Okay, so temperature on the lowest section of second layer, so this is layer number 2, is 6000 Celsius. Temperature at the top is 4000 Celsius. 80% is iron, 20% is nickel. Now question, why temperature at the top section of second layer is lower? Because answer is this, because you have a lot of cracks, you have volcanoes, and because of earthquakes, this heat comes out actually, finally comes out from the Earth's surface. That's why temperature gets lost in this section from these cracks. So that's why temperature here is less than temperature on the bottom section. And the another reason is this, because here and at the top, pressure is less. So if pressure is less, is decreasing, that's then temperature also what? Decreases. If pressure increases, then what is happening? Temperature also increases. So because of gravity, temperature on inner core, pressure on inner core is more than pressure on outer core. So that's why inner core is more hotter than the outer core. And this heat ejects out by those cracks to the Earth's surface. So far makes sense. But I am going to ask you one question, which question is this. Let me check my email, sorry. Okay. Question is this, that why is inner core is solid? So here my question is, inner core is solid. Why? Guys, let me tell you one important thing. Watch it. Iron melting point what does melting point means? That means is iron gets melt in 1350 something like that, close to this Celsius. So iron gets melt, iron converts from solid to liquid at this temperature, 1350 Celsius. Now question is this, the inner core, pay attention, is iron, correct? But temperature of inner core is close to 6000 Celsius. Now my question is this, if iron gets melted at 1350 Celsius, then how is this possible that iron core, which it has 6000 Celsius, it doesn't get melt? It is solid. How? What is your answer? What is your answer? Why inner core it doesn't get melt? As we know, temperature of iron in regular conditions is 1350 Celsius, but inner core temperature has temperature of 6,000 Celsius, but it's not melted. What is your answer? The answer is here. Watch it. If I say this is inner core, okay, watch guys, this is all planet Earth. You have extremely pressure because of that gravity on inner core, much more than, let's say here is, than what? Outer core. The thickness, the amount of pressure on inner core is much more than amount of pressure on outer core. Why? Because of this thickness I see, you know? So because pressure is high, then melting temperature, or let me write melting point, increases too. I promise you, if pressure would be a little bit less maybe than it is today, like it says 140 billion atmosphere. Like if it would be 130 billion atmosphere, it might be inner core would be converted to what? Liquid. So because of pressure, high pressure, when pressure increases, melting point what? Increases too. For outer core, pressure is less than inner core. That's why outer core is cooler than inner core. That's the answer. Okay. What is, so we learned this, correct? What is third layer? Number 3. Number 3, it's actually there you go. This is the layer of number 3. It's called mantle. And later what we have? We have crust. Which mantle and crust, some book in geology they go mantle and crust with same, just they call it mantle, but your book goes with mantle and crust, which all miners, mines, uh, iron, metals, they will be found in mantle. But of course my picture is not correct very well, so this is the picture that we are going to have actually. So the iron inner core is the first core, then the outer core is liquid, then the third one it's called mantle, then the last unit which is like 400 kilometer close, it is called crust. Okay, so this is the model of planet Earth. Any questions so far? So I want to take 3 minutes break, drink water, and I'll be back. Okay, guys. Uh, the next section, it's about Earth's magnetic field. I want to talk about this section. So it's about Earth's magnetic field. Actually, one of the main reasons that why is our planet is a unique planet, the answer is because of Earth's magnetic field. Watch, guys. Geologists and astronomers, they believe that Mars had atmosphere at the very beginning, but because of lack in magnetic field, it couldn't save the atmosphere, so it's gone. Planet Venus, it doesn't have magnetic field. Mercury has magnetic field, but it's very weak. But gaseous planet they have, Jupiter, Saturn, Uranus, Neptune, they have. Why? Because they are actually gas. They rotate very fast, so that rotation is caused. But I'll tell you about that. So, what is magnetic field? Watch. Of course, if you have a magnet has two poles. One is called North Pole, one is called South Pole. And I can tell you that if we have iron's particle, let's say this is a magnet, and you just uh, like salt, drop these particles on the magnet, you will see those particles, they get oriented in making like closed loops like this. These lines, it's called magnetic field lines. Magnetic field lines. Our planet Earth has magnetic field. Now, question is this: do we really have a big giant magnet inside the core, inside the planet Earth? Like if I write N here as here. Do we have a giant magnet inside the Earth? The answer is no. So question, how does Earth makes magnetic field? Okay. So we have one thing which is called electromagnet. What is electromagnet? Electro, what does electro means? Electron. What does magnet means? Magnetic field. Formed by electron. Really? Is electron makes magnetic field? Answer is yes. Watch it. I showed it to you in the class. But guys, this is just very tiny paper. If I rub it on my hair, now it is charged paper. Correct? So this charged paper in chapter 3, I explained it to you. If I showed by like Q, its charged particle, it gives you a field. What kind field it's called this? It's called electric field, which it's force. So one particle, if it is charged, it gives you force. What do we call that force? Electric field. Now, if this charge, if this paper, if it moves by speed of v, v means is speed, velocity. If electric charge moves, it creates electric field plus, of course it creates electric field, doesn't matter if it is station or it is in motion, 100% one electric charge creates electric field. Doesn't matter if is it stationary or is it in motion, it will create electric field. But at the moment when it moves, when the charge, electric charge, if it moves, it will create what? Magnetic field. So please pay attention. So at the moment, right now, see, this is a charged particle. No, it's not. I rub it on my hair, now it is charged particle. It creates electric field. But when I move it, it creates magnetic field around it and electric field, both. Okay? So question is, how does our planet Earth makes magnetic field? What is the answer? The answer is this. Watch it. So here let's say it's inner core. Then let me draw a big core. So this is outer core. Okay, this is not good. Actually, let me see. Okay. Oh, okay. Come on. What's wrong? Oh my goodness. Okay. Let's say this. This is inner core, okay? And this one is outer core. Watch it. What do we have? Here at the lowest section of inner core, we have 6,000 Celsius. At the top section, we have like 4,000 Celsius. Look, what I see here, I see differences in temperature. Differences in temperature we showed by delta T. Delta means is change. So this triangle is called change. Change in T, T means change in temperature. Okay, watch. Change in temperature gives me change in density. Change in density gives me diffusion. I think it's double F. What is diffusion means? Diffusion means is motion. Where that motion comes from? From convection. So what is convection means? Convection means is motion. Who makes that motion? Diffusion. What is diffusion? Change in density. Differences in density. So this is differences in density. What is differences in density? Where it comes from? Differences in temperature. So this T means is temperature. So what I see, guys, pay attention. This is very beautiful, very lovely topic. So here at the lowest section of uh, outer core, liquid outer core, I do have temperature of 6,000. Then at the top section, high section, I do have temperature of 4,000. What I see here, differences in temperature. What is differences in temperature means? Differences in density. Okay, differences in density. So the section that it is hot, it has less density than the section that it is what? Cold. So what is happening? The less density will go up. The higher density will go where? Down. So this makes circulation. This makes up, down, up, down, up, and down. So this is motion. This is called convection. This is called what? Convection. So this is convection. What is convection means? Motion of fluid, motion of gas, motion of air because of differences in density. And that differences in density forms because of differences in temperature. It makes convection. So what is convection means? Remember, convection means is motion. Okay, question. What is moving in the second layer? What is moving in the second layer? What motion of what? Motion of molten iron. Oh, okay. What is molten iron? It's conductor. Yes. It's a metal. This is conductor. What is metal means? Metal means is electron. Not one electron, no. Billions of billions of billions of billions of billions of tons of electrons. So in the second layer, electrons, they move. So these things that they go up and down, in reality they are electron. Oh, I told you. If charged particle, where is that? If a charged particle, what is charged particle? So this is charged particle. Do you know what is charged particle? It's electron or proton. If electron moves, it creates magnetic field. Now in the second layer, because of convection, actually electrons, they move. Motion of electrons creates what? Magnetic field. Now, so motion of molten iron creates magnetic field. So what we have, if I say this is the planet Earth, okay, therefore guys, I can say magnetic field is field. So I am going to have field. They are global lines around the earth. Now question is this. Is this magnetic field formed by convection? Is it enough strong to protect earth from solar wind? Answer is not. So what is happening? So this magnetic field is not strong enough to protect our planet from what? Solar wind, from deadly radiation of the solar wind from the sun. But we see we are protected by the earth magnetic field, correct? So what? We are protected, but here I say, if earth just makes convection, it's not strong enough magnetic field. Yes, it's not. What do you think? But we are protected by the earth magnetic field. The most probably we must have another motion to increase speed of motion. What do you think? Rotation. Here rotation comes in the game. Rotation of what? Of planet Earth. It's called omega. So rotation also increases rate of convection. Therefore, I will say this. Convection plus rotation of planet, convection in outer core, plus rotation of the planet Earth, these, they both together, they increase, let me write actually, they what? Make a stronger magnetic field, which this magnetic field can protect us from the deadly radiation of the earth, of the solar winds. So what we see here, guys, earth makes actually a magnetic field, and the earth magnetic field is a global magnetic field. What is global means? Where is that? Global means is it's global. It covers entire planet. So as I said, we can assume that inside the planet Earth we do have a magnet, but that magnet's formed because of that convection and rotation, so it makes what? Global magnetic field. This is what we have. Now, let me go over next topic, which it's called Van Allen belt. Okay, look guys, this is the picture of Earth magnetic field which it gets protected by, which it protects us from the solar wind. So here is the sun is actually here, correct? So this is the sun, and sun, it's big, creates solar wind. What is the solar wind? These are all charged particles. These are all charged particles. They are electrons. So these are all charged particle, okay? And Earth makes also magnetic field. Earth also makes magnetic field. Now, when these solar winds, which they come actually toward the Earth with 400 kilometers per second. That's the speed, V. So the solar winds, they comes toward the planet Earth. They ejected out from surface of the sun with 400 kilometers per second. 400 kilometers per second, if you do that number divided by 1.69, probably it will be something around 170 AD miles per second. So these particles, they comes toward the planet Earth. When they comes toward the planet Earth, they meet Earth's magnetic field. What is happening? Watch guys. If you have two magnets, one is S, one is N, and the other one, N is here, S is here, you know, because one magnet has two poles. This is called north pole of magnet, this is called south pole of magnet. Now, if you make these two magnets close together, if both poles are like pole, so here they will repel each other. If I get two magnets like this, SN, SN, these two, they will attract each other. So here you have attractive force, here you have repulsive force. Now, solar winds, they are charged particles. When they are charged particles, they move. They move by what speed? By 400 kilometers per second. Okay, I told you, if a charged particle moves, it creates what? Magnetic field. So these particles, let's say these yellow particles, when they move, they are like a magnet. Watch it. When they are, so this is like solar wind, okay, which they are particles. This is like Earth magnetic field. So the solar winds, because they move, they act like a magnet. Now when they meet Earth magnetic field, they get what? Repelled. That's why these solar winds, they cannot go inside planet Earth, inside the atmosphere. If that would happen, we would get skin cancer in less than 6 minutes. So Earth magnetic field protects us from deadly radiation of the sun. Now, inside the Earth magnetic field, we do have two belts, but these two belts, they are invisible. But the strength of magnetic field in that section, it's more than the other section. Who found this section in Earth magnetic field in 1938? In that time, he was one Allen. So they named those belts, that section of magnetic field, by his name, Van Allen. It's called Van Allen belt. So they are like donut shape. Can you see? They are like donut shape. So if I ask you a question, what is the donut shape in what is the name of that donut shape inside the Earth magnetic field? Your answer must be Van Allen belt. So where is Van Allen belt? It's close to 5,000 kilometers from the Earth. So it's between 5,000 to 50,000 kilometers. So it's called Van Allen belt. It is invisible, but by satellites we can measure the strength of magnetic field on that sections. So guys, what is happening now? Sometimes these particles, which they are solar wind, they actually they trapped inside Van Allen belt, and when this belt gets full with the particles, those particles sometimes they leak inside the Earth atmosphere. When they leak inside the Earth atmosphere, because they are charged, and inside the Earth atmosphere we do have oxygen. We do have oxygen, correct? When they go inside the Earth atmosphere, those electrons, those particles, charged particles, they get burned. When they get burned, they make what? Aurora borealis. Or this is called what? Northern light. I had a student, she was living in Alaska. Actually, 2 years ago, she was my student. So she told me that usually during summer and winter, they see sky like sometimes it's like blue color or blue light or green light like this. This is called Aurora borealis in northern hemisphere. And if we go in, excuse me, southern hemisphere, we do have Australian Aurora, oops, Australis, which it is also called what? Southern light. Yes. So this is all about Earth magnetic field that you need to know. So very important is that, guys, Earth magnetic field, remember, protects us from deadly radiation of the solar wind, which they comes from the sun. So solar wind, sorry, so the Earth's magnetic field is like a shield. It protects us. It's like umbrella. It repels the particles that they come from the sun. So when Allen belt, you learned about that in the pictures. And again, if I say this is the planet Earth, and planet Earth has magnetic field, and the sun is here, correct? Now these particles, when they come, they actually they deflect it. They completely change their path, and sometimes these particles they can go through the Earth atmosphere. When Van Allen belt gets full, sometime during winter or summer, these particles, they leak into the poles, not on equator. You won't see light on equator. Why? Because concentration of magnetic field is on the poles. Therefore, on north, you will see northern light if you live in Alaska or Norway or Finland or the countries that they are actually close to poles or above 70 degrees altitude. Yeah, 70 degrees on latitude, or minus 70 latitude in southern hemisphere. So you will see northern light or southern light, aurora borealis or aurora borealis. All right, the next section. Next section, you already know that it's all about the moon. Okay, you did project above the moon, so you know most section of the moon. Just couple things that I need to tell you. Watch, guys. I already talked about synodic period, which is 29.5 degrees, 27.32 degrees. Days, sorry, it's sidereal rotation. So the moon, unfortunately, we couldn't do observation for the moon. So I'm really sorry about that, because campus is closed completely and we are not allowed to go there. But hopefully I will email you on next semester in the fall. If we do this project, we will do it. Hopefully campus will be open in that time, and I will email you, or yeah, then you can come. Okay, so guys, this is the moon. Here you can see the moon's surface actually has a lot of craters and plains. So these craters all they formed because of bombardment of debris, meteors, asteroids. Okay, so the moon's surface is actually like this more. The section that it is dark gray, this section is called Mara. Mara, it's not Maria. It is like it's also called Maria. So this is not Maria, it's Maria, which is same as Mara. Mara means is salty water, is like lake. So astronomers, so this backs to 2000 years ago, they were thinking that these dark gray section on the moon, they are like lakes. So that's why they call them Mara or Maria. But as we know, this section, they formed because of when the moon actually was molten at the beginning of formation of the moon. You know, when they get cold because of tectonic, actually because of motion of molten material, when they get cold, they stay like that. So these are in reality, they are like mountains. They are up and down. Why do we see them as dark gray color? It's because the shade or the shadow of the highlands and lowlands makes shade. That's why they look darker. Okay, so they are actually like mountain. They are like big valleys. That's why they looks dark gray color. Uh, so these are some data that I want you to look at them, please. The moon is cold. Temperature is negative 292 Fahrenheit during nighttime, and during the daytime temperature is 266 Fahrenheit, so it's very hot also. Moon doesn't have atmosphere. Moon does not have atmosphere. So if we go on the moon, two persons, they cannot talk. They can talk, but they cannot hear each other. Why? Because there is no medium to transfer that vibration into your ears. Because sound is mechanical wave, and mechanical wave needs a medium for propagation. Okay, so you know these, so please study this section of craters, Maria, highlands, and lowlands. So one important thing that I want you to pay attention, it is formation of the moon. Look guys, uh, geologists and astronomers, they found when we take the sample, when we took the sample from the moon and we did some study on it, on the craters actually, they found that the moon formed 80 to 100 million years after formation of the Earth. The theory that it is accepted in astronomy and in the science and in geology, it is, let me find that section. The theory that it's accepted, it's called collision ejection theory. So in formation of the moon, the theory that it's accepted in formation of the moon. What it says 80 to 100 million years after Earth formed. What is that? It says a planet like Mars size. Do not forget this. It's called Theia, Thiea, something like that. A planet like Mars size makes collision or hits the Earth and during that the material, the element spreads to the space, and because of rotation and gravity, finally, and a planet like Mars size hits the Earth, and finally what? Moon forms as it is today. Again, this idea, so far by calculations and physics laws and geologies, that they did lab on the materials, on the elements that they found it on the moon actually, when in 1969 they brought some materials, some samples. It is accepted idea. It might change because in astronomy many things change, some ideas, some theory actually. So This is the accepted theory, which is called collision ejected theory. So what theory is accepted in the science so far? In formation of the moon, it is this: 80 to 100 million years after Earth was formed, so this is 80, a planet like Mars size makes collision with the Earth, and those particles, they spread to the space, and because of gravity they rotate, they stick together, and finally they make what? The moon. Let me see that PowerPoint. Yeah, this is what it is. So the impact happened between a planet with Mars size with the Earth, and those particles, they spread into space, and in the same time that collision makes the planet Earth what? Tilt by 23.5 degrees. So remember, so what is happening if this is the Earth, then a planet like Mars size, correct? It makes collision with the Earth. When it makes collision with the Earth, so Earth at the beginning was straight, and then because of that collision, Earth gets tilt with 23.5 degrees, correct? And also moon forms around the Earth. Okay. Now guys, so next Monday is 04. So next Monday is 04/06/2020. Yes, it's here. 04/06/2020. What are you going to have? You are going to have exam number 3, chapter 5 and 6. Or let me say chapter 6 and 7 from 11 edition. What I did, okay? Lecture. Or chapter 5 and 6 in 10 edition. I hope not make you confused. If you have 10th edition, it's chapter 5 and 6. If you have 11 edition, it's chapter 6 and 7. So the lecture that I did it last week and the lecture that I did this week, okay, will be your exam number 3. On next Monday, it will be by Zoom in the same time as I as we have class at 7 o'clock. Okay? You will be with me by Zoom on next Monday at 7 o'clock. I will email you just maybe 2-3 minutes before our meeting. and you will make on the paper like this. Like for example, question number 1, it is, for example, A. Question number 2, for example, is C. Question number 3, for example, is D, whatever. Okay, so you will make like this for me, and when you done, like 7 p.m. to 8 p.m., correct? At 8:15, I have to receive all of these answers. If not, I will not accept it anything after 8:15. So, study chapter 5 and 6 in 10 edition, or 6 and 7, whatever I did lecture. Okay, plus homework chapter what? 7, which new chapter about Earth and Moon. Alright, so I want you to do only review questions, that's all. Only review questions. They are from number 1 to 25, okay? So for next Monday, guys, again, you do have exam number 3, chapter 6 and 7, which chapter 6 is about formation of the solar system, chapter 7 is about Earth and Sun, Earth and Moon, plus your homework, chapter 7. Because the other week will be spring break, so I will not see you for 2 weeks after that. Yeah. So hope you do well, be safe, be healthy, and I wish you all the best. If you have any questions, please email me, and you already have my number, so you can call me or text me. Yes. Okay, guys. Have a good night, actually, and see you on next Monday by Zoom. I will email you everything. Bye, guys. Let me see how can I stop this now. Okay. What is wrong with this? Where is that section now? Oh.